So let us start. I'm just opening one poll there. Just check it. Two questions I have given there. Dash processes can affect or be affected by others, independent or cooperating. And second question is dash places no practical limit on the size. Last 10 seconds. See the results now. So the first question, 67 out of 109 given correct answer. The cooperating process can affect other processes or it can be affected by other processes. So that is correct answer is cooperating, but still around 19% students are saying it is independent. See, if the process is independent, it cannot affect other processes. And second one is actually simple, but still, when I say dash places no limit, remember it is no practical limit. Whenever limit is there, it is bounded. Okay, it is bounded by some sort of size. But whenever there is a no limit, it is unbounded. But I can say even without knowing the knowledge of this operating system, with common sense also you can give answer of this. Whenever there is no practical limit, it's unbounded. Okay, it is not bounded by some sort of limit. 58 students have given the correct answer for this, so that is fine. Rajvardhan Sagare, unable to find chat window. Yes, because I started with training part. So you put this as a question, no problem. So whatever Q and A, you can see the question mark icon there. Here you can put your question. Even you can utilize same thing for answering also. Okay. So for example, let me add one question there. How many IPC mechanisms are there? I'm not able to send actually. I hope it is for yes. How many IPC mechanisms are there? Try to answer this in Q&A, question and answer section. I'll check it here. Yes, yes, I can see answers in the question and answer, no doubt. Fine. So let us continue. Now, number of IPC mechanisms discussed in this textbooks are two. That is fine. One is a shared memory and one is with the message passing. But actually, multiple IPC mechanisms are available. They are possible. Like for example, with pipes. But again, that can come under the shared memory. Even file handling. Can I say file handling as a IPC mechanism? Answer to this could be yes, because one program, I'll open the file, I'll write something in it, and program will simply stop. Another program will open the same file and read from it. Okay, but again in that case, uh, that file can be treated as a shared memory. So that is the reason. Rather than saying two mechanisms, I can say two types. Okay, two categories of IPC mechanisms are there. Now let us continue today's session with interprocess communication. Uh, Yesterday we discussed the classical problem, one of the classical problem, and that is producer-consumer problem. So today let us have a look at the IPC with shared memory. Anyways, this is not in depth. As already mentioned, there is a separate unit on interprocess communication and interprocess synchronization. Okay. So what happens with shared memory? I guess I mentioned this part yesterday also. So for example, there is one process. Okay, for example, this is one process. Okay, there is another process. So two processes are there. Let me call this as process 1 and this as process 2. Okay, then definitely it is possible to have a separate memory segment. So when I say this is process 1, this is the memory bounds of process 1, this is memory bounds of process 2, and now this becomes my shared memory. Okay, this is my shared memory. Whatever I'm typing, is it visible? Anybody please give me a response on this. Yeah, font is very small. Yeah, font is very small. I guess on mobile it is not visible. Let me try to. Okay, what I'll do is uh, let me check if I can share whiteboard. This whiteboard is visible. Now let me do the same thing. Let me type something here. I guess it is visible now. I just written there shared memory in red color. Tushar Katke, can you respond? You can't see. Okay, some delay is there, I guess then. Okay, fine. So what I mentioned is this is the memory bound for process 1, the T1 I mentioned, and this is the memory for process 2. Mute yourself. Mute yourself. Aishwarya. Okay. So now this is process 1 and this is process 2. Then what operating system does is there will be a separate memory segment called as a shared memory, and this memory now will be attached here to process 1 also and to process 2 also. So memory will be attached to both the processes, and then whenever P1 want to communicate something to P2, P1 will simply write there, and it is very simple thing. It is very simple thing. Can anybody tell me how to read and write the memory? Anybody? How to read and write the memory? So very simple. Nobody? How to read and write? Okay, Rajvardhan Sagare is saying, didn't, no, forget about inter-process communication. My question is very simple. How to read and write memory? Okay. Okay, so let me explain. See, that is very simple thing. Whenever you say INTI, let me modify color of this first of all. Okay. Whenever I say INTI, what is meaning of this? When I simply say for example, I'm taking the C language. It is not initialized. It is not initialized because initialization is assigning some value to it. I'm not initializing it. INTI is very simple thing. We are declaring a variable, right? We are declaring. So this is variable declaration. Now, even though we are saying it is a variable declaration, in terms of operating system or in even C language programming also, variable itself is name given to the memory location. So we have memory, right? And then memory, each and every word or each and every byte of memory having unique address, and rather than referring to that address, okay, wherever I say, for example, if int I need say 4 bytes, now 4 addresses will be there. If there is address for each and every byte, there will be now 4 addresses. So let me, if it is possible to draw, for example, it is something like this. In the memory, so these will be the 4 bytes. 4 bytes will be there, and these 4 bytes can be accessed by the name I, and that is the reason we say variable is name given to memory location. It could be single or multiple. Now, if 4 addresses are there, definitely it is the lower address that we keep for the I. And now my next question, what I ask is, when I say INTI, how to read and write the memory? Is very simple thing. Whenever I say I is assigned with some value, say for example 88, actually I am writing 88 here. At this location I am writing 88. So that means whenever we are assigning value to any variable, we are writing to the memory. And whenever the same variable name is used on the right hand side, so for example, suppose here I do something like printf %d and I. Here I am reading the value of variable. Okay, what happens here is, in case of I is equal to 88, yes, here I am writing to the memory location. Fine. Now, whenever I do something like j is equal to I, here again I am actually reading it. Whenever I say something like I is equal to I plus 7, something like this. Now, Here remember it is both read and write because I is on both side of assignment. Okay, so on right hand side I plus 7, this I we are reading, and this I whatever the result of expression is there, we are again writing it. So writing to and reading from memory location don't require any sophisticated function. That is the case. Once memory is attached, and again this is very simple, when memory is attached, remember what happens with malloc. What happens with malloc? We assign some, say for example, if I say 40, malloc 40. What is meaning of this is allocate 40 bytes in the memory. So block of 40 bytes will be allocated, and important thing is what is returned back is pointer. So typically we have some sort of pointer list. P is equal to malloc 40. Prajna Lohar, mute yourself. Prajna Lohar, mute yourself. Okay. So whenever we say P is equal to malloc 40, what is meaning? Malloc will allocate 40 bytes somewhere in the memory, and the starting address will be written back that we have assigned to P. Right? Exactly same thing happens here. Remember, with malloc, it is part of your process only, but with shared memory, it is external to that process, but attached to your process. Fine. So this shared memory will be attached to this process. Definitely, we need some sort of a pointer there. And now using that pointer, we simply modify it. Got it? So that is, now let me, fine. So the same thing I mentioned it here, an area of memory is shared among the process that wish to communicate. So separate memory is there. The communication is under the control of the user process and not the operating system. The reason behind this is very, very simple. Again, as it is attached to the pointer, you can anyways access it. Raman Chame says my voice is breaking. Is it same for all, or is it problem of Raman itself? Okay, you are getting it now. Okay, no problem. Right. So the communication is under the control of the user because once you got the pointer, you can write anything there, right? So there is no control in the hand of operating system. Rather, I can say users get more privilege to access it. Okay. Major issue is to provide mechanism that will allow the user process to synchronize. Because see, whenever you declare a variable, say for example I, maybe that is a shared variable I, and if that is shared variable, then the question is whenever somebody want to read the value of I, because it is part of memory, definitely some value will be there. Most of the time we call it as a garbage, or else we initialize it with some say 0. But again the thing is 0 is value or it is not initialized, because if somebody want to read it, how he will confirm that it is really modified or not. Say for example, in the producer consumer problem, producer generates a random number and put in the variable I, and consumer want to read it. Now the question is, with shared memory, if the value of I itself is 0, is it random number or it is not uh, produced yet? Okay, so that creates a problem. So inter-process synchronization becomes somewhat difficult. I'm not saying it is not possible. It becomes somewhat difficult. Okay, so we need to provide that mechanism. So that, because that will not happen with message passing. Because if message is passed, yes, if message is there, that means somebody has produced the item and available there. If message is not there, it has to wait. Consumers has to wait. That is not the case in case of shared memory. Anyways, we are going to see synchronization later on. So here important thing is there is a need of inter-process synchronization whenever you are dealing with the shared memory. Okay. Now what happens with message passing is, this is the mechanism where process can communicate also and synchronize also. So with message passing, both things are possible, communication and synchronization. How is very simple, as I mentioned. If message is there, read it. If it is not there, wait. So waiting means now I'm stopping the execution of that process, suspending for some amount of time. That is what the synchronization is. And if the message is there, read it. That means you are communicating some sort of message there. Okay. So there are so many things we need to discuss on implementation of message passing. Okay. Processes can communicate with each other even without shared variables. Now how, I think the diagram, yes, here. A separate space, kernel space, is used as a message queue, and processes can send the messages to the message queue and read the messages from the message queue. Multiple processes can share this message queue. Okay, so it's not like shared memory. Separate message queue is there, and like two operations are definitely required. One is to send the message and one is to receive the message. Another design issue I can say is about the message size, whether it should be fixed or variable. That is the question, whether it should be fixed message or variable size message. Okay. Of course, there are advantages and disadvantages of both the approach. Anyways, we are going to see the message passing library in C language with POSIX IPC. That time we'll see, because they support variable, but one part is fixed there. So that is a combination of both. Okay. Now, if process P and Q wish to communicate, the process in message passing is they need to establish a communication link that is required, and this communication link is basically through the message queue. Let me write that as MSQ, message queue. Okay, and then they exchange the messages via send and receive. So two operations are actually possible on this message queue. One is send message, one is receive message. Now these are different design or implementation issues for message passing. First is, how are links established? Now this is logical answer, establish a communication link between them, but how to implement it? Because both processes cannot share their memory segments. So definitely we need to have something else here, right? So that is one thing. Second thing is, can a link be associated with more than two processes? It is not like one-to-one communication. What if I need one-to-many communication? That is the question here. Can a link be associated with more than two processes? Okay, so that is again implementation issue. See, answer to these questions are not fixed. Okay, and that is the reason I mentioned they are implementation issues. They are not problems. Okay, now for example, can a link be associated with more than two processes? Few operating systems may respond it with yes, it should be restricted to only one. Few may say no, more than two is also possible. So message queue can be shared not only between two. It is possible to have more than two. Now, a typical example on Linux terminal, have you used pipe there? Pipes. We use pipe where I guess the key is on keyboard above enter key. In C language, we call that as a bitwise OR operator. It is something like, let me put it here. अशी की असते बघा, like A or B. Now this is used as a pipe, and that is the interprocess communication mechanism used by Unix. But with pipe, only two processes can communicate with each other. With message passing, similar kind of implementation issue is there. Can we utilize this link between more than two processes? So maybe few operating systems say yes, few operating systems say no. So it all depends. It all depends there. Next, how many links can be there between every pair of communicating processes? How many links we need? Like again, if I repeat the example of pipe is unidirectional. So if you need two-way communication, two pipes are required. Does it the same thing required for messages? Maybe, may not be, depends. Now, what is the capacity of the link? So whatever you are providing, whatever the link is there, what is the capacity of that? Capacity in terms of maybe communication, in terms of storage buffer. Okay. Next, is the size of message that the link can accommodate fixed or variable? Now, if it is fixed, what is that size? If it is variable, how you will handle that storage? So, again, we need to discuss on these issues. Okay. Is the link unidirectional or bidirectional? Yes, both is possible. So now, if we study the POSIX message passing library under Linux or Unix, then there are specific answers to all these questions. But because we are studying the operating system concepts part, fine. If message passing has to be implemented, what are the things you need to decide, you need to think of, so that you will implement that message passing. So for example, if I say POSIX message passing, or even system V message passing library. Anyways, we are going to see that practically. Don't worry about it. Whenever we are going to see that, so in case of POSIX message passing, how are links established? Answer to this question is any of the process can establish link. They can create the message queue, okay, and like the call there is MSG get, message get. So queue will be created in the kernel space, and then with MSG get, both the processes can get attached to that queue. Can a link be associated with more than two processes? In case of POSIX, yes. You can have any number of processes, they can utilize this link. How many links can be there between every pair of communicating process? Actually, with POSIX, there is no communication link between the processes, rather the link is between the message queue and the process itself. So there is no need to, for example, for a process P1, it don't need to know how many other processes are there. What P1 knows is there is a message queue and it will simply send message there. Okay. Now what is the capacity of a link? Now in case of POSIX, you can like the next question is whether it is a fixed or variable. Yes, it is a variable, and the capacity of a link depends on whatever the memory. So that is the kernel argument, one of the kernel argument, wherein you can specify the maximum capacity for the message queue. Is the link unidirectional or bidirectional? In case of POSIX, it is bidirectional. So you can utilize same link to send the message and to receive the message. So try to understand what is meaning of this implementation issues. These are not problems. So it is something like you want to go to the college, okay? How you will go? How you will go to the college? Now multiple solutions are there. Now which one you will select? That depends on you. So for example, I'll go with public transport. Maybe I'll go with my own bike. Maybe I'll share with my friend. So few days it will be my bike. Some other day maybe it's friend's bike. Something like cooperating kind of concept, petrol partners, right? But then how to go to the college? If this is the question, it depends. Similarly, these implementation issues depends on the operating system. Okay. Now, how it is done in Windows? Yes, we need to collect the information. How it is done in Linux? Yes, we need to collect that information. In Mac OS, collect the information. But while implementing, operating systems need to discuss on this. Okay. Is this okay? The implementation issues. Now, implementation of communication link. Maybe we can have shared memory, maybe we can have hardware bus, maybe through network. So many options are there. Or logically, maybe direct or indirect, synchronous or asynchronous, automatic and explicit buffering. Now, physical link, forget, we need to discuss on this logical. Direct or indirect, let me check if it is there. Yes, it is there. So these three parts we'll discuss: direct or indirect, synchronous or asynchronous, automatic or explicit. So direct communication. So whenever you want to have a direct communication, then you should know name of other entity. That should be explicitly. So it is something like, for example, I want to make call to my friend. I must know, say for example, mobile number of that. So here name, we are talking about a name. Now if I don't know mobile number, no, I cannot make a call, right? So that is what the direct communication is there. So you can say this is one of the limitations there. Process must know the name of other explicitly. And whenever any process want to send message, say for example there are P and Q, okay, P and Q. So send P comma message, meaning of this is send a message to process P. So whatever message you want to send, you should aware of name of the process also. Similarly, for receiving, receive a message from process Q. This is the message and receive the message from Q. This is called as the direct communication. But again, there is a limitation of this, and this is really uh, difficult to write program making use of this because we studied like the PID is the unique identifier for a process, and this PID always gets changed. How you will keep track of other processes there? How you will know the name? And while writing program, you should already know that how many other processes are there. Okay, like if I want to repeat the yesterday's example, if I have a quad core processor, maybe I want to write four sub processes, four child processes are there. What if there are dual core processor? Maybe I just want to go with two. Does it mean I need to write separate program for that? Or it is possible to check how many cores are there and then utilize that, create those many child processes. So in that case, what about the names? Okay, so direct communication. They are really, see, implementation is very simple. Why? Because we are directly, it is something like sending mail, right? Sending mail. So whenever one person want to send mail to other person, he'll mention the address and whatever the message you want to give. And how to implement it is very simple thing. There is something called as a mailbox, which is the space available on any computer. Even you think of a Linux operating system, and if sendmail service is running there, okay, there is a mailbox for each and every. Where spool mail is a directory there. Where spool mail, and there is a mailbox for every process. So implementation is fine, but for application programmers, it becomes difficult to write programs like knowing name of other process and then writing the program. It becomes difficult. Now, properties of communication link. Links are established automatically in case of a direct communication. A link associated with exactly one pair of communications. That means you cannot communicate between more than two processes. Between each pair, there exists exactly one link. So that means if three processes are there, how many links will be there? If there are three processes, say P1, P2, P3, so between P1 and P2, between P2 and P3, between P1 and P3, three links are required. Now that actually creates a mesh. Now imagine for 4, 5, 6, 7, 10, number of links required will be more. And if the link is unidirectional, then maybe one more link is required, or you could have bidirectional link. Bidirectional is like data will flow in both the directions. Now with indirect communication, what happens is messages are directed and received from mailboxes, and they are also called as ports. So, for example, I want to send a message to the head of the department. Okay. Now, no need to know what is the name of head of department. If I know just email address something like, so for example, I'm just giving hod@kitcuk.in, maybe hodcsc@kitcuk.in. Whoever is the head doesn't matter. So for me, say for example, I want to send the message to director. So director@kitcuk.in. Who is director? I don't know. You're getting it, no? So there is no need to know the name of other entity. So this indirect communication is possible with mailboxes. Of course, the other entities should have access to that mailbox. That means you need to share the mailbox. Okay, if uh, the relationship between the process and mailbox is 1-to-1, then again here I can say communication is happening between just two processes. But if the mailbox is shared, more than two is possible. Okay, so each mailbox has a unique ID, something like the email boxes we have. Process can communicate. Yes, it is mentioned. It is sharing a mailbox. If mailboxes are used there, then link established only if process share a common mailbox. A link may be associated, yes, as I mentioned, with many processes it is possible. Previously, in case of direct, what I mentioned it is between just pair, between just pair. So one pair of communication. So two processes only. Here, no. Even you can have many processes. Each pair of process may share several communication link. Yes, multiple mailboxes you can have. And this link, yes, it could be both way, unidirectional also and bidirectional also. So that is. Remember, these are all theoretical things. Okay, design issues I can say. In case of indirect communication, what are the operations? Operations are very simple: create a new mailbox, send and receive messages through mailbox, and once done, destroy the mailbox. And these primitives can be like send a message, receive a message. Only thing is here previously in direct communication also we mentioned something like here P and Q. But remember there P and Q both denotes the name of the process. Here it denotes the name of mailbox. And the same mailbox, so it is something like, let me go to the whiteboard. It is something like, this is my mailbox, and so this is one process, process 2, process 3, process 4, process 5, and all these processes are actually sharing this mailbox. It is something like this. And now name of this mailbox is something like, as I mentioned, E. And now this is process P1, this is process P2, so on and so forth. Like P3 is there, P4 is there, and P5 is there. So now this allows communication between multiple. So we are sending message to the mailbox and not to specific process. That is what the meaning here is. Send a message to mailbox A, receive a message from mailbox A. But then again question is, if process P1 want to send to P3, because the mailbox is shared between P2, P4, P5 also. Everybody can read. Okay. So how P3 will specify? I just need message from process P1 and not from P2. So those are the limitations. Mailbox sharing, the same thing I mentioned, P1, P2, P3 share the mailbox A, P1 sends, P2 and P3 receives. Who gets the message? That is the case. When P1 sends, who gets? P2 or P3? Now, in this solution, allow a link to be associated with at the most two processes. That means the mailbox sharing will happen just between two processes. That is one solution. Allow only one process at a time to execute a receive operation. That is another solution. That means if P1 sends, then whoever want to read it, receive it, that must be synchronized. Only one process at a time to execute the receive operation. That is the meaning. Okay. Third solution is something like allow the system to select arbitrarily the receiver, and then the sender will be notified who was the receiver. Okay. So See, whenever you select any of the means of communication, definitely there are certain questions that need to be handled. Whenever we see the message passing library, POSIX message passing library, you will come to know that all these questions have been addressed there. Whether that is correct or wrong, it definitely depends. Okay, but they are addressed there. Now, second part, after direct and indirect, whether this message passing should happen like synchronized or unsynchronized, or synchronous or asynchronous, or blocking or non-blocking. So, message passing, it could be either blocking or non-blocking, where the meaning of blocking is synchronous. That means, say for example, it is mentioned here. Whenever you make use of blocking send, the sender is blocked until the message is received. So whenever process P1 want to send something to P2, P1 will send and it will wait there. It will wait for what? It will wait for P2 to receive it. So this is called as a blocking implementation. Now what is blocking receive? Whenever you want to receive a message, it will be blocked until the message is available. So like P2 want to receive the message from P1, but P1 yet not send the message. P2 has to wait. So this is called as blocking send and blocking receive. Now whereas what is non-blocking? Non-blocking send is the sender sends the message and simply continues. So message will be sent in the maybe say for example mailbox or whatever shared message queue is there. Message will be sent, that is done, sender will continue its execution. That is non-blocking send. Okay. And what is non-blocking receive? Now this is interesting. How it is possible to have a non-blocking receive? Say, just I give an example. P2 want to receive the message from say P1, but P1 not yet send it. It has to wait. If it has to wait, then I can say it is a blocking receive. Whereas what is non-blocking receive? Yes. Now here comes like if else. If the message is available, read the message. If the message is not available, don't wait. Come with some error. Maybe call it as a null message. It is mentioned here, null message. Call it as a null message. But don't wait there, because if you are waiting there, it is blocked. Okay. So blocking calls are synchronous, whereas non-blocking calls are asynchronous. Even different combinations are also possible, and which is the same thing done in Linux and Unix. For example, blocking send and non-blocking send and blocking receive is used. So what is selected? Let me select another color here. Non-blocking send is selected and blocking receive is selected. Meaning that this is very simple. We have a common space called as message queue. Sender sends the message in a synchronous way and simply waiting there. Simply continue its works, not waiting there. Simply continue its work. Whereas if process want to receive something, then process will be blocked. So this combination is possible. So this is default behavior as I mentioned, but even blocking send, non-blocking send, blocking receive, non-blocking receive, all four combinations are possible. There are different effects of this again. For example, here I think you don't see this. Something wrong has happened there. Here, this is the code for producer consumer. Of course, not complete code. This is very trivial code. I know it is not visible to you, but let me read it. Message next produced. So next produced is the item of type message. While true, so this is infinite loop. Produce an item and send. That's it. Produce the item and send it. Okay. Where something like this. This is the code for the consumer. Message next consume while true, so it is infinite loop again. Receive the next message. So receive next consume. So this is the space where you consume the element. So just producer is infinite loop and consumer is again infinite loop. That's it. Now the third aspect is about buffering. So what is the size? What is the size? So the size we expect here, different implementations are possible. Okay. For example, with buffering, what we can say is there is a queue of messages. Queue of messages attached to that link. We could have a zero capacity, some bounded capacity, or unbounded capacity. This is difficult to implement because of limited resources. Because once we say buffering, what happens is memory is required there. So infinite length sender never waits. So for unbounded capacity, sender no need to wait. But how to implement it? Do we have unlimited memory? No. Finite length of n messages. Meaning of this is finite length of n messages. Sender must wait if the link is full. This is mostly used. And zero capacity is what? No messages are queued on a link. This thing is also possible, but remember the sender will be blocked in that case. Sender must wait for the receiver. Okay. So buffering of messages. It is something like whenever you are talking about something, okay, you are actually sending some sort of items. Then in that case, how many items you can put there? That is what the buffer is. Okay. So for example, I'm talking about some say mobile number. If I say it is something like 98235678212245, something like that. Now, how many digits you will remember? That is what the capacity is there. But if it is something like I say 9, then you write it 9, then I say 8, then you write it 8. So it is something like I am sending, now I am waiting. Why I am waiting? Because you are writing it. This is exactly perfect example of zero capacity. So there is no queue at all. I have to send one digit, you receive it, you give me feedback that you have received, I'll give the next one. Kind of stop and wait. Okay. Whereas with bounded capacity, yes, I know that I can remember 4 digits, so that is my capacity. So it is something like 9422, something like this, 9422. Now I'm waiting after 4. I am waiting after 4 digits. So 4, that is your capacity. After that, yes, maybe you need to write down it 9422, something like that. Then maybe I give next 4 digits, something like that. So that is what the so sender has to wait when that buffer is full. That is what the bounded capacity. And what is unbounded capacity? Just go on talking. No need to worry because there is unlimited space available. Infinite length buffer is there. Practically, this is difficult. Practically, I'm saying. right? So that is about the buffering. Examples we'll see tomorrow. Okay, so we'll stop here.